Today's lesson will focus on probability. Probability can be broadly defined as being the chance of an event occurring. You might not know this, but a lot of the decisions you make are actually based on probability. For example, choosing to wear your raincoat in the morning when the skies are grayish, or choosing to drive to the second to next gas station when you're running on empty, or choosing not to eat that piece of broccoli today if you're not sure if it will still be good tomorrow or not. So we will start by reviewing some basic probability theory and calculations. We will start with classical probability, where everything has an equal chance of occurring. A typical example of this is flipping a coin. When you are flipping a single coin, what are the two different results you can get when you do this? That's right, heads or tails. These are the possible outcomes of the probability experiment you just did, which is flipping a coin. When you name all of the possible outcomes of a probability experiment, you are determining its sample space. What would be your sample space, in other words, all possible outcomes, for the probability experiment of flipping not one but two coins? Let's check it out. Indeed, coin 1 could be either heads or tails, and coin 2 could be either heads or tails, independently of what coin 1 actually is. So all of these possible combinations, so these 4 different outcomes, would be the sample space for the probability experiment of flipping 2 coins. Another way to illustrate sample spaces is through a tree diagram. We will draw a tree diagram to find the sample space for the gender of 3 children in a family. Since there are 2 possibilities, either a boy or a girl for the first child, we start by drawing 2 branches from a starting point and label one B and the other G, as we have here. Then, if the first child is a boy, there are 2 possibilities for the second child, whether it be boy or girl. These possibilities are the same if the first child is a girl as well. And we follow the same procedure for the third child. Now, to find the outcomes for this sample space, you have to trace through all of the possible branches, beginning at the starting point. Now, for example, if we start at the beginning and always follow the top branches, one of our outcomes would be 3 boys. So our sample space, in this case, actually has 8 different outcomes. Now, when we talk of probabilities, there are 4 very important rules that you should know very well. These rules can help you solve problems and also double check your answers when we're going to do exercises. Rule number 1 is probabilities can never be negative or greater than 1, which is equal to 100%. Rule number 2, if an event cannot occur, its probability is 0. An example, what is the probability of a volcano erupting in Sherbrooke within the next week? I think it's fair to say that the probability of that is 0. Rule number 3, if an event is sure to happen, its probability is 1. An example, assuming you will not die at least before tomorrow, what is the probability that you will take at least 1 breath in the next 5 minutes? I believe the answer to that is 100%. Rule number 4, the sum of the probabilities of all the outcomes in the sample space is 1. We'll come back to that one later on. Most probability problems asks you to find the probability of not only one outcome, but for 2 or more outcomes. As such, we must distinguish between outcome and event. An event is a set of outcomes for a probability experiment, and an event can have either one or more than one outcome. I'll show you an example here. Say you're at a fair and you decide to play a game. The gamekeeper says if you roll a 6 with this die, you will win a prize. So the event that you want to occur is rolling a 6. You have one single outcome. To win, you must roll a 6. Since you have only one outcome, this is called a single event. On the other hand, if the gamekeeper says that you'll win a prize if you roll an odd number, then you have 3 desirable outcomes: 1, 3, and 5. As such, this is known as a compound event. Let's roll the dice again. What are the outcomes for the event of obtaining an even number? By taking a look at the sample space, we notice that there are 3 outcomes that answer this criteria for this event, which would be obtaining a 2, a 4, or a 6. Should we just ignore the other numbers? Well, of course not. The values 1, 3, and 5 are considered the complementary event, which is denoted by E bar. The complementary events are the set of outcomes in the sample space that are not included in the outcomes of event E. Here's a trick to help you figure out if you have determined correctly the complementary event. When taken together, the outcomes of your event and of your complementary events make up the whole sample space. To calculate classical probability, we have to use this formula. In this formula, we have P of E, which is actually the probability of an event occurring. This is usually what we're looking for. We also have N of E, which is the number of outcomes for that event, which will be divided by N of S, which is the number of outcomes in the sample space. Now, let's do an example. Imagine again that we're rolling a die, and we want to know the probability of us rolling a 2. Well, our event has only one outcome. Our event, remember, is noted as E, capital E. Has only one outcome, which is rolling a 2. Now, in the formula, we're looking for P of E, the probability of the event, which is rolling a 2. So we will use N of E, so the number of outcomes for that event, which is 1, and we will divide it by the number of outcomes in our sample space, so 1 out of 6. It means that our probability of rolling a 2 is of 1 out of 6. Now, how about the probability of rolling an even number? Well, in our event, again noted as capital E, we have 3 possible outcomes: rolling a 2, a 4, or a 6. So in our formula, N of E becomes 3, which we divide by 6, the number of outcomes in our sample space. So we have 3 chances out of 6 of rolling an even number. We can easily simplify this into 1 chance out of 2. Now for a third example, let's imagine that our event is of obtaining a red ace when picking a card from a deck of cards. For that event to occur, we have only 2 outcomes. Either I pick an ace of hearts or I pick the ace of diamonds. So in our formula, N of E becomes 2 because I have 2 outcomes for that event, and N of S is 52 because I have 52 cards in my deck of cards. We can simplify this, actually we should simplify this, to 1 out of 26 chances of us obtaining a red ace when picking a card from a deck of cards. You'll notice that I have been using fractions to indicate probability. You may also use decimals or percentages if you're more comfortable with these. Remember, Rule 4 states that the sum of the probabilities of all the outcomes in the sample space is 1. We know that in the sample space we have all the complementary events and the events in itself. So 1 is equal to the probability of the event plus the probability of the complementary events. Rearrange that in these 2 ways, and it states that if the probability of an event or the probability of the complementary event is known, then the other can be found by subtracting the probability for 1. Well, that's it for today. See you next time.